You know how it is. Every single day, your feed is just slammed with headlines about some new study. This one food will change your life. Doing this one thing is a total disaster. It can feel pretty overwhelming. So let's grab our detective hats, pull out the magnifying glass, and learn how to really figure out what's a real discovery and what's just noise.
Okay, picture this. You're scrolling, and you see this headline pop up. New study. People who floss daily have higher incomes. I mean, your first thought is probably, wait, what? Am I supposed to start flossing at my desk to get a promotion? It sounds kind of bonkers, right? Well, this is exactly the kind of case we're going to crack today.
So, that's the big question, isn't it? How do we, as savvy headline detectives, tell the difference between a genuinely important finding and something that's just a complete and utter fluke? That's our mission for this explainer.
All right, every investigation has to start somewhere. And for us, step one is just describing the evidence we have right in front of us. This isn't about jumping to conclusions, it's about getting a clear look at what the data is actually telling us.
Now, the main tool for this job has a fancy name, descriptive statistics. But don't let that fool you. All it really means is summarizing your clues. The source material calls it numerical data used to measure and describe characteristics of groups. In plain English, it's just about painting a clear, simple picture of the data you've collected.
So, what's the very first thing you do as a detective? You try to find your typical suspect. You look for a pattern. In statistics, that means finding the center of your data. What's the most common or average value in the whole group?
The most common way to do this is with the mean. This is what pretty much everyone thinks of as the average. You just add up all the numbers, divide by how many numbers there are, and bam, you've got your mean. Super straightforward.
But then you've got the median. This one is the true middle-of-the-road value. If you lined up every single data point from smallest to biggest, the median is the one sitting right in the center. And here's why that's so useful. It doesn't get totally skewed by one or two really extreme scores, like a billionaire's income in a survey of a regular neighborhood.
And finally, we have the mode. This one's maybe the easiest of all. It's just the most popular value in the set. Whatever number shows up the most often, that's your node.
Okay, so finding the center of the data is a great start, but it's only half the story, right? A good detective doesn't just know where the clues are. They know if they're all clustered together or scattered all over the place. We need to understand the variation.
The quickest, simplest way to get a feel for this is the range. You just take the highest number in your set, subtract the lowest number, and that's it. It gives you a fast, bird's-eye view of how wide the spread is.
But if you want to get a little more sophisticated, a little more powerful, you use what's called standard deviation. This is a brilliant tool that tells you, on average, how far each data point is from the mean. A tiny standard deviation means all your data is huddled up nice and tight. A huge one means your data is all over the map.
All right, we've carefully gathered and described our evidence. Now comes the really ambitious part, the giant leap. We're going from what we know about our small group of people to making a big claim about, well, basically everyone.
And this is a really important distinction. Think of it like this. Descriptive statistics on the left, that's about what we know for sure, based on the data right in our hands. But inferential statistics, on the right, that's all about making an educated guess about the whole world based on that tiny little sample.
So, to put it formally, inferential statistics are the tools that let us draw conclusions and make predictions about a population based on a sample of data. We're trying to take what we learn from, say, 100 people and see if it applies to 100 million people. It's a big deal.
So if we're making this huge leap, how can we be sure the pattern we saw wasn't just dumb luck, a random coincidence? Well, we need a fluke detector. And lucky for us, statistics has one built right in.
That fluke detector is called statistical significance. At its core, it's all about probability. It's a test to see how likely it is that the results you found are real and not just some random accident that happened in your specific data sample. It's our confidence meter.
So how do scientists actually measure this? They use something called a p-value. And the golden rule you'll see almost everywhere in science is this: p is less than 0.05. If the p-value is below that threshold, it means there's less than a 5% probability that the result was a fluke, and that's usually considered good enough to publish.
So the process for a researcher is pretty straightforward. Step 1, you calculate your p-value. Step 2, you check, is it less than 0.05? And if the answer is yes, then you can be reasonably confident that what you found is a real pattern and probably not just a random fluke.
But hang on a second, we are not done. Just because a finding is real and not a fluke, that doesn't automatically mean it's important or that we should care about it. For that, we need one last tool in our detective kit, the magnitude meter.
You see, statistical significance, that whole p-value test, it answers one question, and one question only. Is the difference real? Is there a genuine pattern here, or is it just static?
But that leads to a much more important, real-world question. Is that difference actually meaningful? So what if people who floss earn more money? Is it $1 more a year, or is it $30,000 more a year? Those are two very different realities.
And to answer that question, we use something called effect size. This is the so what statistic. It measures the strength of a relationship, its practical importance. It tells you if the effect you found is a tiny little blip or a massive game-changing discovery.
And there you have it, your complete headline detective toolkit. You start with descriptive stats to describe the evidence, you use inferential stats to make a leap to the wider world, you check for statistical significance to ask, is it real? And finally, you look at effect size to ask the most important question of all, does it even matter?
The point is, now you've got the tools. You can look right past that flashy headline and start asking the really smart questions about the data behind it. So, with your new toolkit in hand, what headline are you going to investigate first?